Let's try to apply this limit comparison test again. This time we're going to try to test the following series for convergence: the sum of n squared plus 2n plus 1 over n to the 4 plus n squared plus 2n plus 1. And the terms here are a rational function in n. Well, the first thing always to check is that the terms are positive, but there's no problem here because n is always positive, so both numerator and denominator are positive. Now, when the terms of the series are a rational function in n, the rule of thumb is to compare the series to a p-series that we form as the sum of n to the p over n to the q, where p is the highest power in the numerator and q is the highest power in the denominator. So in this case, we're going to compare to the sum of n squared over n to the 4, which of course is the p-series, the sum of 1 over n squared. And we know all about this series because it's a p-series. We know it converges. So as prescribed, we take the limit as n goes to infinity of the quotient of the terms of our given series over 1 over n squared, and reshaping that becomes the limit as n goes to infinity of n to the 4 plus 2n cubed plus n squared divided by n to the 4 plus n squared plus 2n plus 1. And now, of course, this is the limit as n goes to infinity of a rational function in n. So we divide by the highest power in the denominator, which is n to the 4, and we get the limit as n goes to infinity is 1. And this is certainly a finite number which is bigger than 0, so we can conclude that both series converge in this case.